Welcome. This video is going to explore the idea of MapReduce. So MapReduce is this framework that Google has described, and it underlies how they do a lot of their processing. Basically, it's a way of describing information processing in a way that's very naturally parallelizable. So we can take an algorithm that we can describe with MapReduce and very easily split it up between multiple machines and have different machines processing parts of the job. So MapReduce is essentially just a map and a combine. And first we're always going to do a map over some list. So I might map the plus block over a list of numbers. So if I do that, you can see it adds each number to itself. If I do a map times, it says basically map, take the current number times itself. So we're going to square each number. You can see we end with 9, 4, 16, 3 squared, 2 squared, and 4 squared. And then the combine step is to take that list and smash it together. So if I take the square of each number and I add those up, I get what's called the sum of squares, which is an important item for some kinds of calculations. If I'm doing, say, the standard deviation of a list, I need to do something like this. So here's the final thing. If I run this, I get 55. 25 plus 1 plus 9 plus 4 plus 16 makes 55. And I've calculated the sum of squares. And we're always doing the map first, so it's the inside part. We want to start with that recipe and make sure we're doing the right thing to each item. And then the combine is how we put together the results. And the way that this is parallelizable is that if Google runs a map job on a list of numbers, that can be split up over an arbitrary number of machines. One machine can handle the first couple numbers, the next couple, and they can work completely independently. And then some other machines can be doing the combine. They can be waiting for the results to come. Maybe one machine is waiting for the results to come from the first guy, the 5 and the 1. And another machine's waiting for the results from the 3 and the 2, and it's going to put those together. And then some other machine is going to put the results together from those two machines. So we can have a whole cluster of machines working together to do the calculation. Or, in our case, we can have just one machine doing all the work. And it doesn't really matter with the way we're specifying how to do the algorithm. So there's one example, sum of squares. Let's cook up another one or two. It's always going to be this kind of framework. So the next one I want to look at it doing is taking Andrew William Scholler and producing just the initials. All right. So first I've got a sentence to list block to turn this into a list, because these tools are designed to process lists. And so let's, from the Andrew William Scholler, I want to map. The first step is to figure out how to reduce this, how to produce the right information from each item. So Andrew needs to become A, William needs to become W. Basically, I just need to get the first letter of each word. So let's figure that out. There's a letter 1 of word. I'm going to take that off and just say letter 1 of, and make sure it's right in the center of that gray circle so I get the border. Letter 1 of the current word, AWS. Alright, now I want to actually kind of produce a string from that, a sentence, so I need to smash those back together. So I smash things together with join. So join is going to be the combine operation. I'm going to do my mapping, and that's going to be the list. Come on. Let's move this to a better position. There we go. So we're going to combine with join items of our mapping process. And we get AWS, the initials from that sentence. Let's look at a slightly more complicated example now. Songs. I've got a list of Beatles songs. All You Need Is Love, Hey Jude, And I Love Her, and Yesterday. I want to come up with a count of how many of these songs have the word love in them. So the mapping process, I've got to figure out a way to kind of turn this into a map and a combine. Right? If I could turn these into numbers, so each song, I'll look at the title, and if it's got love in it, it's going to count as a 1. If it doesn't, it's going to count as a 0. Right? So I'm going to need to have some logic that does that. So I'm going to start by making a block called has love. And let's do sentence has love. And this is going to either report a 1 or a 0. So I'll just make it be a reporter. Okay, so I've got to figure out the logic for this. For looking at something like all you need is love and deciding whether or not the word love is there. Well, probably the easiest way to do this is to remember that I can ask if a particular list contains a thing, contains a particular word. I can ask, hey, does this list contain love? And I know I can break up a sentence into a list. All right, so I've got, let's take our sentence into a list. And what sentence are we going to turn into a list? We're going to take whatever sentence gets passed in and turn that into a list. All right, so if we just go kind of test this out, so let's say I start with the sentence, all you need is love. All right, if I turn that into a list, it looks like that, only it's need instead of need, but that's not a big deal. If I ask, hey, does that sentence contain love? The answer is true. If love is not there, and I'll just mess it up, then the answer is false. Okay, so all you need is love. Does that contain love? The answer is true. And I want to turn this into either a 1 or a 0. So what I could do is say, well, if it has the word love in it, we're going to return 1. We'll report 1. Otherwise, if it doesn't have love, then that counts as a 0. All right. So this doesn't make sense outside of the block, but at this point we can move it back in. And it's not always going to be this, right? It's going to be the particular sentence. And let's go try out that block. So I made it as an operator. So let's try, and I love her. That's a 1. Let's try yesterday. That's a 0. Alright, so if I take this block, and instead of saying one particular song name, I say blank has love, and I map that over this list of songs. So I'm going to do the copy trick again, just so it doesn't make this disappear. We don't technically need a copy, but it just prevents the display from wigging out on us. So if I do take my songs list, and I map, does each one have love? I get 1, 0, 1, 0. Yes, no, yes, no. And, well, if I want to know the total number there, all I have to do is add up those values, right? I've got a bunch of 1s and 0s. And if I add those up, I get 2. 2 songs out of my list have the word love in them. Right? We can solve lots of problems using this framework. The 2 keys are just figuring out how to map the values we're starting with in the list into something that we want, either like the squares of numbers, or into a more useful form like just the first letter, or a 1 or a 0 instead of a whole song name, and then how to combine those, whether we are just doing pluses, whether we're squaring things, whether we're keeping the maximum value, any of the ways that we can combine items.